This mock examination covers 3.1.3, which is all to do with searching algorithms. So our first question is here, and it says the algorithm in figure 4 is the binary search algorithm designed to search for a value within an array. Now you've already seen this on a previous question, but now we're trying to look at actually the theory behind a binary search. So here you've got here, why would the binary search algorithm shown in figure 4 not work when the array contains 5, 3, 13, 8, 7, 2, 6, 5, 5, 43? Okay, now here's your biggest clue. If you know the theory behind a binary search, you should know that a binary search must be in order. So it has to be sorted before it can work successfully. Now this array here has not been sorted, and the algorithm doesn't sort the data as part of its code. So we know that this binary search will not work correctly because the array has not been sorted. So it's only worth 1 mark, so we know we need a short, sharp answer. Why? So we're just giving the reason. Why would the binary search algorithm shown in figure 4 not work when the array contains this? Because the array isn't sorted. That answers the question. It's a short, sharp answer. It's worth 1 mark, so that's all I need to put. The next question is asking us which search algorithm is being used in the example in figure 5, and it wants me to justify my choice. So there's that command word again, justify. So you should know by now that justify is give reasons. So which search algorithm is being used in the example? Now we know we've got either a linear search or a binary search. Now a linear search looks at each list item in turn to see if it can be a match. A binary search splits the data and keeps splitting it until it finds a match. So what do you think this code is actually doing? So we've got input search term, so that could be any search term, it could be Fred for example. So at the beginning match is equal to false, the record number is set to 1, the record position is set to null, and then it's saying do compare current record with search term. So the current record that it's on, compare it with the search term. So the search term I've said is Fred. And then if matched, then true, record the position number. And then keep doing this until end of the list or it finds a match. So we're looking here at this and thinking about a linear search and a binary search. What that's doing is it's looking at each record in turn and it is seeing whether it can find a match. So it's a linear search. Now it's telling me there to justify my choice and it's worth 2 marks. So I'm going to get 1 mark for saying that it's a linear search. So this is a linear search algorithm. This is because it looks at each item before moving on to check if it is a match. Okay, so I've said that it's a linear search, so that's my 1 mark. And then I've given my reason, which is a valid reason, and that will give me my 2nd mark. So our final question is telling us that there's been a data set and it contains 5 million items. So that's quite a lot of items there. So the item that matches the search term is at position 4,800,000. So it's quite a way into the data set. And it's saying which searching algorithm should be used to find the search term. And it says justify your choice again, and it's 2 marks. So we know we're going to get a mark for choosing the correct type of search algorithm, and then we're going to get another mark for putting a valid reason for our choice. So again, we've got linear and we've got binary. So a linear search looks at every single item, so it's all 5.8 million items before it finds a match, whereas a binary search splits and splits. It's split that way actually, splits and splits and splits and splits until it finds the match. So we know for a fact that a linear search will take 4.8 million comparisons before it finds the correct match, whereas the binary search is going to be a lot less than that. So it's saying a sorted data set contains 5 million items. The item that matches the search term is at position 4.8 million. Which searching algorithm should be used to find the search term? The binary algorithm should be used, and then we've got this justify, so we're putting a because at the end and we're giving a valid reason, because the linear search would take 4.8 million comparisons before finding a match, and a binary search would be completed in less comparisons. Okay, and that is going to give us our 2 marks because we have said the correct term and we've given our justification.